Section 1.3, Part 2. I inadvertently skipped one of the examples on Part 1, so I will backtrack. Example 1 actually reads on the handout, determine whether the given equation defines y as a linear function of x. So y as a linear function of x. So what they're really asking me is, can I take that equation and write it in the form y equals mx plus b? It then says, if so, write it in that form. So part A is giving me the equation 3x minus 6y plus 7 is equal to 0. And all we're asking is whether or not we can isolate or solve for y. So let's try it and see. So let's move the 3x to the other side. And we're going to go ahead and move the 7 to the other side also. So we'll do all that in one fell swoop, as they say. So negative 6y is equal to negative 3x minus 7. And we're going to divide everything by negative 6. So y is equal to negative 3 divided by negative 6. I can reduce that fraction to a 1/2 x. The negative divided by the negative is going to make that a positive 7/6. So the question is, yes, I can rewrite this as a linear function in terms of x. And there it is. And we can take out the y and rewrite it as f of x equals. So f of x is equal to 1/2 x plus 7/6. That's y equals mx plus b. We know that that's a linear function. Part B gives us 2x minus 3y squared plus 8. So what was driving the conversation over here is that the exponents on the x and the y were all a positive 1, which is what makes it a line. We're going to notice right off the bat that we see an exponent of 2. That means it is not linear. So I cannot write this one as a linear function in terms of x. So I can't go any further with it. So in other words, if we tried to isolate y, we would end up with something that is not a line. It's going to involve a square root, which is non-linear. So, sorry about that. Okay, example 3. Now I'm back on track. Example 3 talks about a cost and revenue function. Definitely an application from the business world. So it says that a manufacturer has a monthly fixed cost of $40,000. So the fixed cost is $40,000. And the fixed cost for a manufacturer would be things like insurance, rent on the building, utilities, possibly, I don't know, what else would you need? Maybe the supply, mostly those things. So it includes the insurance, utilities, rent, everything you have to pay no matter how much you produce. A production cost of $8 per unit. So the unit costs are $8. So $8 per unit. So if I produce 5 units, it would be 8 times 5. If I produce 100 units, it would be 8 times 100. And then the product sells. So this is the variable costs. Just trying to get all the information on the board. And then it sells for $12 a unit. So there's our information. Let me read that again just to make sure we all agree on the information. It says the manufacturer has a monthly fixed cost of $40,000 and a production cost of $8 for each unit produced. The product sells for $12 per unit. Part A is asking us to find the cost function. So your cost function, C of x, is equal to your variable costs. That's going to be multiplied by an x because it depends on how many x's you produce. So x represents the number of units you're producing. And to that, you're going to add your fixed costs. You'll notice I again am going for that mx plus b, where m, the slope, is really this variable cost. So for our function, we have $8 per unit. So $8 for every unit produced, where x is the number of units, plus the fixed cost of $40,000. So this is saying that if you produce no units, if x is 0, you still owe $40,000 in overhead. Let's go ahead and define our x to make sure we're on board with that. So x is the number of units or goods that you're producing. Part B is asking you to find the revenue function. So the revenue is simply how much you sell each unit for. Well, we're selling them for $12 per unit. So if I sell 100 units, I make $1,200. If I sell 5 units, I make 12 times 5 or $60. So the revenue function is simply the cost per, the selling price per unit times the number of units. That's the easy one. Part C is asking for the profit function. So the profit function is always going to be your revenue minus your cost. It's how much money you're bringing in, then take away how much money you're spending, and that gives you your profit. So for us, we'll take our revenue, which is 12x. I'm going to subtract off our cost function, which is 8x plus 40,000. Don't forget to distribute the negative sign. So that would be 12x minus 8x minus 40,000, or our profit function. So 12x minus 8x gives me 4x minus the 40,000. And there's your profit function. And then finally, part D says, compute the profit or loss corresponding to production levels of 8,000 units and 12,000 units. So when X is 8,000 units, so I've made and I've sold 8,000 of these units, we're going to find P of 8,000. All we have to do is replace that X value with 8,000. And if you do that, you get a negative 8,000. So if I produce and sell 8,000 units of whatever good I'm making, I'm going to be in the hole by $8,000, not where we want to be. But if, however, X is equal to 12,000, so now we've produced 4,000 more. So if I plug in 12,000 into our profit function, we'll find that we make a positive 8,000 in profit. So somewhere between 8,000 units and 12,000 units is what we call as the break-even point. We've broken even in terms of our broken even in terms of our profit, and our revenue and cost are equal. And we'll look more at that idea in the very next section. Revenue and cost. Example 4. Example 4 talks about Social Security. It says that Social Security recipients receive an automatic cost of living adjustment once each year. Their monthly benefit is increased by the same percentage that consumer prices have increased during the previous year. So my raise next year depends on the consumer prices this year. Suppose consumer prices have increased by 5.3% during the preceding year. So 5.3% from the previous year. A wants us to write a function. It says express the adjusted monthly benefit of a Social Security recipient as a function of his or her current monthly benefit. So if we let X be the current amount that you get each month, what we're saying is that you've now gotten a raise. And how much of a raise is 5.3% over what you currently were getting? So if you get 100% and tack on the 5.3%, you figure out how much you have in the new year each month. So you can call it whatever you want. I'm going to call it Y for Y equal MX plus B. So the current amount is X. We're going to take 100% and add on the 5.3%. Let's see if this makes sense in terms of just numbers. So last year, we'll say last January, let's say that we let X be $2,000. So you got $2,000 in Social Security. Then this January, you're going to make 1.053 times that 2,000. So with any luck at all, you've made more money than you made the previous year in January. So if we take our 1.053 and multiply it by 2,000, we'll see that this January you're making 2106. So we can see the adjustment for the cost of living that your Social Security went up by. Part B is saying if John Smith's monthly salary is now $1020, what will be his adjusted monthly benefit? So they're going to come in and let X equal 1,020, and they want to know what you would make in the next year. So then y would be equal to 1.053 times the 1,020. And if you do that on your calculator, you should end up with $1,074.06. So we can see, yes, indeed, we're making a little bit more money this year than we made last year on Social Security.